right, so we got known cross sections was 2 days ago. Yesterday was volumes of revolution, and today is still volumes of revolution, but we're going to use what's called the shell method. And with yesterday, we took circles, and we did areas of circles. We did a whole bunch of circles, added them up, got volume. Well, instead of doing circles today, we're going to take a cylinder, the area of a cylinder, add it to another area of a cylinder, to a cylinder, to a cylinder, and an infinite amount, and you come up with the volume that way also. Well, the area yesterday of a circle is, of course, pi r squared. Today, the area of the lateral surface area of a cylinder, if you cut open a can and then flatten it out, it's a rectangle. Well, the top is the circumference, 2 pi r, and then you have, of course, the height of the cylinder or the can or whatever. So the area is 2 pi r h. So that's what we're going to be integrating. This is number 33 out of the book. We're going to do A through D and just kind of investigate how we find these volumes. So away we go. Letter A says we're going to revolve this around the x-axis and find the volume. And we're going to work our way towards an answer of 6 pi over 5. We already have the answer. So over the x-axis. So this is what we're revolving around. So let's try to duplicate this on the other side. Something like that, roughly. Now if we pick an arbitrary y somewhere in the shape, of course, and if we were to make the 180-degree turn, we're right there. And then if we go all the way around, this is kind of what the cylinder would look like. So that represents one of an infinite amount of cylinders. And then we could do this cylinder right here. That would hit about right there. And we could do a bigger one and a bigger one. Eventually they become smaller again. So we could add up an infinite amount of cylinders, get the volume. So we are picking arbitrary y values, and that tells me that we're going to integrate on y. So this is going to be dy, which is good because we have x equals. Well, the area is 2 pi times the radius times the height. That's what we have to fill in. The radius of all of these cylinders is just the value of y, because y is the distance from the x-axis, and that's exactly where our radii are sitting, from the x-axis. So the radius is just simply y. Now the height of all of these cylinders, after we've picked our arbitrary y value, is, well, we plug that into the formula and we would get the height. So we have 12 times y squared minus y to the third. All right, well, let's do the math on it. We'll integrate by hand one time, and then we'll use the calculator for the rest. So we have 2 pi integral from, I didn't write that yet, 0 to 1. 0 to 1, we're integrating on y, so we'll use the y values. This is going to be 12y to the third minus 12y to the fourth, dy. And 0 to 1. We have 2 pi times, that's going to be y to the fourth, so 3y to the fourth minus 12 fifths y to the fifth. Not dy, but 0 to 1. So we have 2 pi times 3 minus 12 fifths. Well, that's 15 fifths minus 12 fifths, which is 3 fifths, which is 6 pi over 5, and we got it. We got the answer. Questions on this one yet? All right, so what happens if we rotate this around, letter B, the line y equals 1? So we're going to rotate this around that horizontal line. So before, we rotated around the x-axis, that's a horizontal line. What about this one? Well, let's repeat, let's do the 180-degree turn. Something like that. We're still going to pick an arbitrary y value between 0 and 1. And if we do the 180, or actually the full turn, this is what the cylinder would look like. So we're integrating again from 0 to 1. Oh, yes, that's true, 0 to 1. 2 pi r times h dy. Remember, y values go from the x-axis. So the y value is from here to this edge right there. That's y. But the radius is sitting right here, right in there. So to get that y value, we take all of this, which is 1, and if we minus out the y value, we get what is left over. So the radius is 1 minus y. And then the height is exactly the same thing. The height is 12 times y squared minus y to the third. All right, so what if we factored out the 12? Made this 24 pi, 0 to 1, 1 minus y, y squared minus y to the third, dy. Then we'd have 24 pi, 0 to 1 of y squared minus y to the third minus y to the third, y to the fourth, y to the fourth, minus y to the third plus y to the fourth. Is that right? No. Anyway, try that again. I know how to FOIL, trust me. Y squared minus y to the third minus y to the third, y to the third, y to the third, plus y to the fourth, dy. So we have 24 pi, 1/3 y to the third minus 1/2 y to the fourth, right? Because I need a 2 there, and then plus 1/5 y to the fifth from 0 to 1. What my b is? I need 4 pi over 5. 24 times 1/3 minus 1/2 plus 1/5. Four pi over 5. Is that what I needed? Yep, that's what I needed. Any questions on that? It's a little tougher to find the radius on this because you got to do a little subtraction. Because that radius is kind of up there in space. It's not up against an axis. All right, letter C. The line y equals 8/5. The answer is 2 pi. 8/5 is 1 3/5. So that line is up here somewhere. Now if we draw the reflection, or the 180-degree rotation, something like that, I suppose. You pick some arbitrary y right here. That's going to be about right there. And this right here is the cylinder, at least one of infinitely many. Now we're still integrating from 0 to 1. We have 2 pi. We need the radius, and we need the height. Now the radius is going from the arbitrary y up to 8/5 right there. So that's the radius. So to find the radius, we go from 0 to 8/5. So there's the 8/5. And we're going to minus out this piece right here, which is the y value from the x-axis. So I need 8/5 minus y. And then the height's the same thing. It's the function value. So we have 12 times y squared minus y to the third. Well, that'll be fun to find that out. 2 pi, 0 to 1. How about 24? 8/5 minus y squared minus y to the third, dy. 24 pi and 0 to 1. How about 8/5 y squared minus 8/5 y to the third. Inside is minus y to the third, and last is plus y to the fourth, dy. So 24 pi, 0 to 1, 8/5 y squared. About negative 8/5 minus another 5/5 is negative 13/5 y to the third, Almost got it. We got 24 pi times 3. Let's see, 3 1/3. How about 8/15 y to the third minus 13/20 y to the fourth plus 1/5 y to the fifth. 0 to 1. So this is the point where I reckon just use your calculator. 24 times 8/15 minus 13/20 plus 1/5. Go to, what did I do wrong? Why is that wrong? What's that now? Oh, I didn't put one at the beginning, did I? Insert here, and boom. 2. Was it 2 pi? Yeah, I think the answer was 2 pi.
Yeah.
Yep, 2 pi. Any questions on that one? Finding the radius can be a little bit challenging. All right, the last one. Over the line, y equals -2/5. So if this is only going up to 1, 2/5 is maybe down here. And then we can make the reflection right there. I'll pick some arbitrary y value. That's going to put it right about there. We have 2 pi, integral from 0 to 1 of the radius times the height. We're integrating with respect to y. So I need the radius. And you can always do top minus bottom. That should always work. So here's the y up here. So we have a y value up here. And what we should really do is add on 2/5, because this is where the radius is kind of anchored down right there. So that's y plus 2/5. Well, that's what y minus -2/5 is going to give you. It's going to give you the y, this y value, plus another 2/5. So y plus 2/5. That's the radius, and then the height doesn't really ever change. It's that formula right there. So we have 24 pi, 0 to 1 of y plus 2/5. And then we'd have y squared minus y to the third. dy. 24y, 0 to 1, we have y to the third minus y to the fourth. First, outside, inside, plus 2/5 y squared. And last, minus 2/5 y to the third, dy. So 24y pi 5/5 minus 2/5 is 3/5. Y to the third minus y to the fourth. 2/5 y squared. dy. Better get 2 pi again. So 24 pi times, that's going to be 3/20 minus, that's going to be y to the fourth. 1/5 y to the fifth plus, that's going to be 2/15 y to the third, 0 to 1. 20th, hopefully this all becomes 2. So 24 times, not plus, times 3/20 minus 1/5 plus 2/15. Got it, 2 pi. Oh, no, I don't want to stop this yet. Let's find some white space somewhere. I get this a lot. Am I integrating with respect to x, or am I integrating with respect to y? So let's try to sum it up. Use this chart. Hopefully it'll help you. But if you still have to ask me, that's what I'm here for. Or look at the key or whatever you have to do. Let's talk about just revolving, what we did yesterday. So if you had some sort of washer and you were revolving around the x-axis and all these washers are adding up along the x-axis, then you're going to integrate with respect to x. And your equations better be y equals x. It's got to be in x, right? That's say y equals if you're integrate with respect to x. If your washers are lining up along the y-axis, then you're going to integrate with respect to y, and your equation better be x equals something in y. It better say x equals. With now the shell method, if you are revolving around a vertical axis, some sort of vertical, whether it's the y-axis, or x equals 5 or x equals 10, then you're picking your arbitrary x values for your edges, so you'll integrate with respect to x, and of course it better say y equals for the height. And then finally, the one we did, we were revolving around some sort of horizontal axis, so you better integrate with respect to y because you're picking the edges of your cylinders based on y. So then your equation better say x equals. So that's how you pick whether you're integrating on x or y. And so hopefully that little chart comes in handy for you because it gets a little confusing.